Let's look at, we looked at graphs, we looked at order pairs, mappings. Now let's look at an equation. This is probably a bit harder, but not that much once you realize what it is you're focusing on. So let's go back and think about this for a second. A function requires that you take an object in the domain and produce a single output. A mathematical function consists of a series of operations in combination. So let's take our basic operations and take a look at them. And consider this one. Example 9 is y equals x plus 2 a function. Now, to answer this question, just go through the mental exercise. Pick any two numbers, add them together. Does the result produce a single value or more than one value? So, for example, let's just pick two numbers, 7 plus 2, that equals 9. -7 plus 1, that equals -6. So every time I grab two numbers, how many things does that produce? 8 plus 2, that equals 10. The answer is just 1. So now, again, as a reminder, the variable that is solved for, y, is going to be the range value, so this must be the domain value. So now here we have our range. And what's happening in this function? Well, if you look at it, we are just adding two numbers, right? If I, for example, say x equals 4, then what am I doing? I'm just going to take 4 plus 2, and the answer is 6. So that produced one value, and you can quickly start seeing that no matter what you pick, say x equals -10. So now we're going to evaluate this, and -10 goes to -8. So again, here you have the order pair, 4, 6, -8. -10, 8. So every time I choose a value, it only takes me to one place. So yeah, this is a function. How do I know that? Again, every time you add two numbers, all you get is one value. Back out. So this is a function. What about this? Example 10 is multiplication. Let's look at multiplication, the next operation. Y equals 3/2 times x. So of course, also a reminder, it's addition and subtraction. If you subtract, you do exactly the same thing. Is 3/2 x a function? Going through that same exercise as we asked what happens when we multiply any two numbers together. Again, I go 2 times 3, that equals 6, 7 times 5, that equals 35. So every time I multiply two numbers, I only get one value. But then when you look at this equation, what's happening? Well, all I'm doing is multiplying two numbers. I'm multiplying 3/2 times some number that I have not chosen to get y back out. So you can see it's the same thing. No matter what I choose here for x, when I multiply, I'll get just one value corresponding to that value I choose. So for example, if I choose x equals 4, what do I get? I get y equals 6. So enter 4, 4 connects to 6, and so on. We can keep going forever doing this. Every time I put one value into this value for x, I get one value back out. So this is a function. So that equation is a function. So again, just to recap, all I'm doing is asking myself, what does this function, this equation represent? And here I'm just adding, add two numbers, I get only one out. So no matter where I replace x with, I get one out. So output, it's a function. So this is a function. Same thing with multiplication. This is a function. What about if I combine them? Like in example 11. Well, same thing. What am I doing here? I'm taking multiplication followed by subtraction. So I multiply, I get one number. Subtract, I get one number. So if I enter anything here for x, let's say 2, what do I get back out? Exactly one number. So now 2 corresponds to 1. And you can see that if I kept doing this over and over again, each time I enter a value here, I only get one output. So again, this is a function. What about this one? Okay, well, now it looks more complicated, but what am I really doing? I am, again, example 12 is y equals 5x cubed plus 4x minus 1. And is that a function? And again, just look at the operations. The input values in one term is being cubed, which is multiplication. The results only one output. So when I put a value here, I get cubed. When I put this value here, again, I multiply by constant 4. I continue to multiply, then at the end, add, subtract. So yeah, no matter what I choose for x here, I only get one value. For one value input, I get only one value output. So this is a function. How about this example? Example 13. Is y equals plus or minus 2x a function? And let's see what happens. Again, I'm going to assume that x is domain. Why am I assuming this? Because right now this is solved for. So the variable that is solved for is going to belong to the range. So my input, domain is my input. So what happens when I put an input here? Well, let's see what happens here. So I enter, for example, let's say x equals 2. What do I get out for y? Well, y is actually now equal to 2 values. If I write this in order of pairs, I get that I entered a 2, and the output, there's 2 different outputs. One's a 4, but this says also I get a -4. And you can see that no matter what I enter here for x, I get 2 values always. So, but again, all I need is one instance of this, where I'm getting in, putting one thing and getting 2 things back out. So this is not a function. I entered one item and I got 2 items back out. So this is not a function because of that. How about this one? Is x squared plus y squared a function? Now notice the variable y is not solved for. Okay, so now we have both things one side. Assuming that we're going to declare the variable x represents the domain value, let us solve for the variable y. So I'm going to come over here and just solve for y. I'm going to subtract x squared from both sides. Then I'm going to take the square root of both sides. But remember what happens when you take the square root of both sides. You want all solutions. So when I do this, I need to put a little plus and minus here to remind myself that there's 2 possible answers. So here I get y plus and minus x squared. And now we're back to the same scenario as this previous problem. I enter a value here, like say 1, and that produces 2 values back out, right? So for example, let x equal 1. So what happens when I do that? 1 squared is 1. 4 minus 1 is 3. And I get square root of 3 and negative square root of 3. So 1 has produced 2 different values. So this is not a function. And you notice, hey, both times you had this little plus and minus thing. Is that normally what happens? And right now, yeah, that's really all that happens. You know, we have no really good way of doing this, of getting, again, you saw that when I do addition, multiplication, and subtraction, you produce, in division as well, you produce only one output. So most of our equations are just based on that. So yes, I need the little plus and minus. But here, for example, I had a situation where I started with x squared plus y squared as a squaring part here that had caused a 2 output. And by the way, what is this picture of? If you were to draw this picture, what does it look like? You can verify this for yourself. But the picture of this is the following. Okay, I'm going to do a pretty lousy job, but imagine what I'm drawing here is a circle. So this represents a circle of radius 2. And you can see again that it fails the vertical line test. So this is definitely not a function. But this is the graph of this equation. So not a function, but it is a relation. Now, if you think about it, most of the time when you're asking a question and expecting a response, you would like it to be a function. That is one response to your question or to answer to your question. Sometimes that is not the case, however, and the response veers off into different possibilities. But typically we like functions just for this reason. Hey, if I have this, what do I get? Well, if the answer is this or this, then you're going, gosh, I get two different things. But when it's a function, if it's one thing, you're happy. Also, here's another reason why we want to know if something's a function or not. So as far as algebra, mathematics, there's many different reasons, but here's one reason. When we do these procedures later, depending if it's a function or not a function, our procedures will veer off. So for functions, we'll go into one process. For non-functions, we have to go into a slightly different process. So identifying them allows us to then understand which process we're about to undertake to get to do whatever it is that we're trying to do.